Hello everyone, I'm Sandesh, PhD candidate at the University of Colorado Boulder. Today I will present our work Converge, QoE-driven multipath video conferencing over WebRTC. Video conferencing has been the most popular internet application since 90s and has been seen a tremendous growth. Many factors influenced this growth. One is the computational power in the devices. The cameras that are present in the mobile devices are better with the resolutions, and the number is also increasing. There are also applications that utilizes these multiple cameras so it can capture best of the multiple world. The next generation network is growing in order to provide the better bandwidth and latency sensitivity to these kind of mobile video applications. Despite of all this growth, video conferencing is still suffering. We measured the performance of the conferencing over WebRTC by driving around the Boulder region. We used a full HD resolution where the required bandwidth was 10 Mbps. As we see in the graph, the bandwidth dropped below the required bandwidth multiple period of time, and it even reached a point of 0 kbps, during which the frame rate suffered significantly, where it dropped frame rate as low as 1 and latency increased as high as 4 seconds. Using the multiple network path could be a potential solution that could provide a required aggregate bandwidth. As we see in the window 0 to 20, if a T-Mobile cannot provide the required bandwidth, it can be compensated by Verizon. Or in a time window, if Verizon cannot provide the required bandwidth, could be compensated by T-Mobile. Or a window where both of them provide a better bandwidth, which can only lead into better QoE. So Multipath can provide required aggregate bandwidth, support multiple camera streams, and provide a stable video calls with better QoE. WebRTC is a de facto standard that is present for the real-time communication system and is supported in almost all the browsers, in almost all the devices, and across different operating systems. So we built a multipath WebRTC standard for the first time. We initially built 3 variants of multipath WebRTC in order to understand the existing schedulers from existing multipath protocol. We borrowed one from MPTCP, which is the first multipath transport over the TCP. Similarly, MP-Quick, which is the first multipath protocol over the Quick, and MPRTP for the RTP. With the multipath, we were expecting the performance would be improved compared to single path variant. But however, as we see in the graph, all the 3 multipath variants QoE dropped below the single path. In the same graph, we can see that Converge solved all this problem and provides a better frame rate, reduced freeze duration, and better end-to-end latency. Another important observation to be seen is the FEC overhead is very aggressive in all the multipath variants. So how did Converge achieve this? Converge actually utilizes 3 important components, and I'll briefly explain it here. First, initially, it uses multiple paths to start pushing the RTP packet, and then the feedback is sent for individual path based on the packet flow on each path. And in a conferencing system, encoder usually encodes the raw frames coming from the camera, and the encoded frames are of 2 types. One is keyframe and another one is the delta frame. Keyframe is the most important frame which is required to decode all the delta frame. If a keyframe is missed, delta frame cannot be decoded. The frames are then converted into RTP packets, and again there are different types of the packets that carry different information. Example, a PPS packet which is needed in order to decode a given frame, or a FEC packet which is needed in order to recover a lost packet within a frame, and SPS which is needed to decode group of frames. So if a scheduler simply schedules the packet based on the path characteristics and fails to understand this decoding sequence of a video, then the QoE could easily drop as decoding sequence breaks. And hence, our video aware scheduler understands this decoding sequence and carefully assign the packets on the path. In network over the time, network dynamics could change, and which can easily disturb the QoE at the receiver side. The reason is the small packet buffer and the frame buffer that is used in conferencing in order to retain the time sensitivity. Our video QoE feedback actually detects the path that can drop this QoE due to its dynamics and tell the sender maybe fine-tune the number of the packet over the individual path or the path that caused the QoE drop. We also designed a path-specific FEC approach, which is not as aggressive as the WebRTC stable-based approach. So the FEC overhead is minimum and the QoE trade-off is better. Last but not the least, the uncoupled congestion control in the Converge utilizes the individual path and derive its sending rate and compute the final sending rate as the summation of individual path sending rate. And finally, that rate would be given to the encoder and it continues to encode the raw frames that is coming from the camera and the process repeats. I will briefly explain one of the challenge that we solved in the paper due to time constraint. Consider we have two paths, path 1 and the path 2. We can assume the path 2 as the slow path. Usually the slow path are the path that causes, that suffers from a higher loss or higher delay or has a limited bandwidth. Now let us consider we have three frames, Fi minus 1, Fi and Fi plus 1. Fi minus 1 is the key frame. Now, if a scheduler does not understand Fi minus 1 is the key frame and is the most important frame, it might end up scheduling the packet on the slow path. And if any of the packet from the slow path suffers a loss, then it can create blockage in the packet buffer. As packets continues to come from the fast path, in order to make space for the incoming packet, some of the packet could be dropped. And as a frame is constructed or as all the packets of the given frame is gathered, it would be pushed into the frame. But however, in the frame buffer, we check whether the decoding sequence is met between the frames or not. And when the frame buffer notices the required key frame is missing, it simply drops the frame and requests the key frame from the sender. At the same time, it also purges the packet. It belonged to the frame that it dropped. All this leads into limited number of the frames or no frames in the decoder that could easily cause stalls in the video. Well, our video aware scheduler understands this decoding dependencies and assigns the packet, like important packet, like packet of keyframe on a fast path, which could avoid all these events. We measured the performance of Converge in various network conditions by driving around the boulder regions, walking in the campus in a static case. Due to time constraint, I will present the driving scenario results. As we see that Converge utilizes both WebRTC single path component and provide a better throughput. Compared to single path WebRTCs, the frame rate is maintained around the minimum required frame rate of 24, and the latency is kept minimal compared to its single path component. We also measured the performance of Converge by using different number of the camera stream, as the goal was to support trending application with multiple camera streams. As we see that despite the number of the camera stream, Converge achieves smaller latency compared to single path component. And as the Converge uses its own FEC component, its overhead is minimal and the utilization of those FEC packet is maximum. And hence it provides a better overhead and utilization compared to single path WebRTC. We also measured the performance or the normalized QoE performance of the WebRTC compared to single path, as we see that the throughput of the Converge is almost equal to summation of the individual throughput from single path component. FPS is again the minimum value of 24 with the smallest stall duration, and the quantization parameter achieved is smaller compared to single path, which indicate a better video quality. We also compared the performance of Converge to single path WebRTC and existing multipath scheduler variants, and even the WebRTC connection migration mode. We only show the PSNR image quality here due to time constraint. And as we see in the graph, Converge provides a better PSNR over per frames compared to all the existing method. And compared to WebRTC Verizon, it provides an improved 6 dB gain of image PSNR value. In conclusion, we built a multipath WebRTC over legacy WebRTC that is compatible with almost all the browsers and devices, and it utilizes three important components like video aware scheduler, QoE feedback, and path specific FEC module. So it utilizes the path along with better video QoE. Converge supports the trending video applications, provide a stable video call with better QoE, and is compatible with the existing WebRTC. Thank you.